Good afternoon, everyone. So welcome. We're going to talk about AMD ROCm software and Azure integrations today. So there are a lot of challenges to AI adoption today. It is a complex and integrated solution. The complexity creates headwinds for enterprise adoption, both for executive leadership and for IT strategists. So we list a set of top challenges here, but this is not exhaustive, right? It is a growing concern for anyone trying to deploy AI at scale. And there are a multitude of options here, and all of these technologies evolve rapidly, and trying to keep up with them is a big challenge. So what does AMD do? AMD enables a world-class suite of solutions. We are the only provider of CPUs, GPUs, networking hardware, cluster-level design, and an integrated software suite that overlays all of this hardware innovation that we have made. So the ability for AMD to unlock value is immense. So let's talk a little bit about scaling with AMD Instinct GPUs on Azure. AMD provides the best tokens per dollar performance for large language models like Llama, DeepSeek, etc. DeepSeek performance specifically, we've been able to show more than 2x of improvement, both in throughput and latency, compared to corresponding H200, NVIDIA H200s. So the best models today, you could look at a 2x performance improvement, and then you have TCO advantages that add on top of that performance improvement. And AMD Instinct is immensely designed for the integration with Azure services. For example, taking AKS, the Kubernetes service from Azure, we integrate that tightly for the ND MI300X v5 instance. So what this allows you to do is take the data and the pipelines and everything that you have on Azure and drop in an Instinct platform GPU and unlock the value that you need, that you can get with an AMD Instinct GPU. We also support trusted launch. So this allows you to have a secure layer to start VMs with trusted launch. And we'll go into some of this detail in the next few slides. We're going to touch on the performance especially and the integration for GPU platforms. Let's talk about AMD CPUs. So the EPYC platform, there are more than 40 AMD EPYC-based VMs available in all Azure public regions. This gives you immense choice. And you can find the compute to fit your needs. VMs that have the ability to address general compute, confidential compute, HPC, AI training, inference, storage, visualization, gaming, and more. For each one of these, we're able to tailor the EPYC GPUs that you can use. And more importantly, you can make room in your AI budget. Modern AMD VMs help you save more than 26% in your cloud OpEx. And we also support a wide range of AI inference workloads. AMD's EPYC platform provides you the best CPU platform to deploy AI workloads on. And let's talk about local AI development with Ryzen AI. We've partnered with Microsoft to enable easy deployment of models across all of the accelerators, GPUs, NPUs, and CPUs. with Windows ML support. We also have industry-leading memory capacity with the Ryzen AI Max Plus with 128 gigs of memory that you could use between the CPUs and the GPUs. And currently, AMD is in its third generation of AI PCs. And we have a broad set of AI PCs for local development. This includes the Strix Halo platform, which is the Ryzen AI Max Plus. There's the Premium series and the Advanced series. So we can tailor the solutions that are available for you. And then we continuously invest in the simplification of deployment. So there are tools that are being built that can enable easy deployment, easy development on the Ryzen AI PC. All right, so let's talk about ROCm. AMD ROCm is open, it's proven, and it's ready. It's open because we are a fully open source software stack. And what this allows you to do is you can customize it to your own needs. And it also addresses concerns of, for security, you can audit it. And if you have any air gap requirements, you can do that too. And this is especially important for sovereign AI deployments. It is proven. AMD ROCm is deployed at the largest national labs. For example, El Capitan and Frontier are all running on ROCm. And it's ready. It's ready because we are currently deploying at scale, not just at the national labs, but also in large hyperscalers, large enterprises. So ROCm is ready for business. So let's talk a little bit more on the developer ecosystem and what are we doing for development. And no points for guessing what that is from. So there is a build system called the ROC that we are working on that allows you to develop just like how AMD internal engineers develop. So the development environment has been made exactly the same. What that means is we want to enable you and the ecosystem to be able to develop just like an AMD engineer. And this has been augmented with a robust CI/CD pipeline and immense amounts of testing that has been invested, that has been hooked up to the exact same development pipeline. Why is this important? We are seeing increasing numbers of community contributions, people who have been able to take what ROCm has provided and go do things that unlock value for them, right, for those customers. So ROCm is an open source software ecosystem for an end-to-end AI stack that you can customize the way you want. And we've also accelerated how fast we release ROCm. We've gotten to a biweekly cadence of increasing inference, training, and other software components are being released every 2 weeks. So we have shrunken how fast we have been able to run all of these tests and give you a quality product every 2 weeks. This is unheard of even in the incumbent ecosystem, right? And the next thing is ROCm, we are taking it everywhere. And what this means is the Strix Halo laptop that I use to the Instinct GPUs that I deploy on has the same PyTorch interface. It has a GPU that's built by AMD, and it can work. And you can prototype on it. You can develop your little kernels there. And you can then deploy at scale in the back end. So all the way from the client to the cloud, we provide you a pervasive AI software story that is then backed by a pervasive AI hardware story. Obviously, all of this comes in different flavors. We have ROCm on Linux, which is very robust for training, inferencing. That's our standard go-to. Recently, we had launched ROCm on Windows using WSL. Again, that is, has been out there and has got a lot of good reception. What we have been working on recently is ROCm on Windows. And this now is actually available in preview in the ROC community build. So if you're a little advanced user and want to try it out on your Strix Halo laptop, it's just a pip wheel that you can install, and it's functional, and you can play with it. And if you have any feedback, let us know. But more importantly, it's all open source. So you can actually build exactly what we are building inside AMD. And if there's anything that you have to do to fix it, we welcome those changes, and it'll be part of the next nightly release. So that's an important change that we've made. And then coming later, we are also cognizant of past AMD users that want to use the community source and be able to fix and tinker with AMD platforms that they've had from the past. And so older AMD GPUs are increasingly being added to our CI/CD pipeline. And it's supported in a community-first fashion. And then we're going to modular releases. And so what this does is it gives you the ability to just take parts of the stack that you need. ROCm runs across multiple operating systems, multiple GPUs. Traditionally, we've had a one-size package that you would have to use for all of these deployments. But increasingly, we are getting down to a very, very fine-grained control of the software that you need. You just can install that piece, and it makes it easy to deploy. This makes it really good on deployments like AKS, where you just want to deploy a specific GPU target with a specific customization, and you want your Kubernetes footprint to be very lightweight because it allows you for scale. And you don't want to be carrying around more than what you actually need. So that's also something that we've been increasingly focused on. So let's talk about the ecosystem. Open is not just open as a source control system or a build system, but also as an ecosystem. And what we mean by this is we want to truly enable every one of these open source ecosystems that are within the periphery of what we support, right? And we've been working with the PyTorch team very closely. We started with day 0 support for models. The last year, every major model that was released has had AMD ROCm support out of the box. And now we have started to make it out of the box performant. And what that means is the day a model is released, it will not just work, it will work performantly. And this is very important because what this means is you no longer have a lag between what you could do in the incumbent closed ecosystem and what you could do on an AMD ROCm platform. And we've done this for Llama 4, the Qwen models that came out, DeepSeek. And to this day, since DeepSeek was launched, AMD is the fastest platform that you can serve on, right? And we'll talk about that in a few slides, where the Azure team and us, we work together, the AMD team work together, and we have a blog on how to spin up an instance, how to just run a few Docker commands, and you'll be live with a DeepSeek inference serving platform. And it's about 2x faster than equivalent H200s. So performance is one part of it, but we also continually work on feature set enablement for PyTorch. All of the latest features that PyTorch supports, we continually support. For example, flex attention, all the native attention algorithms that PyTorch supports, we have been adding support as soon as they become available. The other big ecosystem play is Triton. This is an important part of the ecosystem because it allows you to move from a CUDA-based programming model to a Triton Pythonic-based programming layer. And this allows for easier entry into GPU programming from the workforce, from new college grads. And then it allows you to target multiple platforms. And so we have been investing heavily in Triton. And obviously, Hugging Face is a big go-to. And so right now, we run about 2 million models out of Hugging Face every night. What this provides is a comfort that AMD's software stack is proven and ready for deployment. And we do that nightly, 2 million models. And then once you get to serving, we are invested in the entire ecosystem. VLLM, in fact, this week, we're going to be getting rid of the ROCm fork of VLLM, and everything's going to be upstream, which means you take upstream VLLM, and it'll just work on ROCm platforms. And VLLM, we've enabled it with all the CI/CD pipelines so that they're also tested. So any change that goes into all of these ecosystem projects get tested every day or every night. SGLang, we have a very, very good relationship with. And we've been doing a lot of good work with them on enabling the SGLang serving framework. And there are others, like in distributed inference. So when you want to set up multiple of the MI300 nodes, you can actually do disaggregated prefill or distributed inference with technologies such as Mooncake. And then there's a whole wide variety of platforms like Onyx Runtime, TensorFlow, JAX, DeepSeek, and DeepSeek, obviously, and OpenXLA, et cetera, that we are fully invested in. So the surface area of AI, from a software standpoint, is covered by ROCm. So let's spend a minute on the layering of the software stack. So obviously, we have AMD GPUs that run on across from the iGPUs, the discrete GPUs, and the Radeons, and then the Instinct platform. But then you have data center infrastructure, containers to make it easy to deploy, and then we have the ROCm layer on top. So this, just taking another zoom into it, I'm not going to go through all of these over here, but what you can rest assured is anything that you have in your current deployment, we have an equivalent one-to-one for. And it's mature and tested, and it's deployed at scale. So if there's anything that you don't, if there's anything that you have that's beyond what's here, let us know. We will make sure that surface area is covered. So let's go a little bit into AMD ROCm for Windows. So like we mentioned, Linux on Windows, WSL has been supported already. The new nightly builds that are going out for PyTorch for native Windows support is available. And later in Q3 and later this year, we'll have official support for it. And then obviously, Onyx EP, we have robust support for, and to enable Windows ML. Good. Now let's go through a few of the important points that we have been focused on for the future of AI software on ROCm. These are a set of innovations and investments that we've been focused on for what will be coming in, what is currently available and what's going to be coming out in the next few weeks, months, et cetera. So let's start with inference serving. So inference serving is a new class of frameworks that have come out in the past few years, like in the past year or two. PyTorch used to be as high as you got to for frameworks, but now there's another layer with all of the advancements with KV caching and page retention, et cetera, where when you start serving at scale, you need to invest in a framework that is aware of those requirements. So a lot of this work traces its roots back to research that came out of UC Berkeley. So we support VLLM, SGLang. We do support TGI. We support pretty much any serving framework that's out there that has any solid user base that you want to deploy on Azure. So let's take a second with SGLang. They really invested in a few new algorithms that helped unlock a lot of performance. They did, typically it was like prefill and decode, and they'd come up with new ways to kind of merge them, and they had something called extend attention, and now they have speculative decoding. Again, all of those are also being developed and made available on VLLM. But this is part of what makes AMD's ecosystem-based approach very robust and very fulfilling to watch too, because there are 2 open source projects that are increasingly being the leader in serving infrastructure, and they keep pushing each other in terms of like the capabilities and the performance they unlock. And that advantage gets down to each customer that deploys with us. So this is a very stark contrast to a proprietary serving solution that you may have that does not bring in these rapid pace of innovations. If you look at how many patches go into VLLM or into SGLang, it is amazing to watch the rate of pace of development. And obviously, we also support TGI from Hugging Face, and that is also a very robust framework to serve LLMs on. Let's talk about DeepSeek. So this one, if there's only one slide that you have to kind of remember from this talk, it'll be this one slide. When DeepSeek was launched, we already had worked with them to have day 0 support. And we had day 0 performance support. And the performance to this day, if you deploy DeepSeek on an MI300X, you get up to 2x better throughput and latency. Obviously, the proprietary frameworks are trying to catch up. That's OK. But we are still the best right now. And this translates directly to a TCO advantage. With this scale of difference, obviously competition is going to catch up and things keep moving. It's like a Formula 1 race. There's always like someone pulls ahead, someone catches up. But just the ability to like pull this level of performance is something that I'd like you to internalize and take away if that is the only one slide that you would remember. And then there are obviously price tokens per dollar, calculus that you can add on top of this. That'll give you an even better TCO advantage when you deploy large LLMs at scale. So it's not just DeepSeek. It's not just it's not a one-trick pony, right? We want to be able to consistently be performant across all of the Halo models. And I just call them Halo models because those are the ones that everyone talks about. So right now, it's DeepSeek and maybe Llama 4, maybe Llama 3. But Llama 3.1 405B really set the benchmark on size and scale for a dense model. And even in that, you get about a 2.1x tokens per dollar advantage over a H100 deployment. We're talking an order of magnitude better TCO advantage, a performance advantage, and then a TCO advantage. So this will be the second slide I'd ask you to internalize. So the performance is good, and the software is ready. So let's go from inferencing to training. Training is also an area that AMD is increasingly spending a lot of time and effort And AMD has done large-scale deployments. All the national labs, AMD is the leader at the national labs, El Capitan, Frontier, et cetera. So networking and developing software for a distributed system is part of AMD's engineering ethos. And now training on top of it is another layer that we've been building on. And so let's take a look at how it stacks up. So we support, just like on the inference side, we had VLLM, we had SGLang, we had TGI. On the training side, we support JAX with or without max text. We support Megatron LM. We support PyTorch with all of the Torch Titan, FSDP, et cetera. So any of the frameworks that you have familiarity with, we cover that surface area, right? And so this should allow you to port any of your training jobs onto an AMD platform when you spin up a Azure 𝗦𝗽𝗲𝗀𝗃𝗃 instance. So training feature sets is one part of it. But we also need to be able to make sure it scales. Scaling, and I'm sure everyone's heard about AI scaling laws, et cetera. So what we want to show you here is exceptional linear scaling. And we say exceptional because it's not, you'll never get to linear scaling, but it is really good for what we're showing you here. So this is up to 128 nodes with Llama. And we've been able to scale with minimal performance degradation, right? And that's 90% plus efficiency. So this ties into the TCO advantages, but also the flexibility that you could get with an AMD ROCm-based platform paired with an Azure instance. So let's say instead of 128 nodes, you want to go to 256 nodes. You just add that on, and your near linear scaling kind of takes you there, right? So it gives you the flexibility, the scalability, and the performance in one package. And obviously, it's also faster time to market for model training. So let's talk a little bit more on, PyTorch itself has a lot of robust training capabilities, and increasingly Torch Titan, Torch Tune, all of which we are very heavily invested in. So let's take another look at our performance metrics. So here, what we're trying to do is just show you what can you expect when you look at FP16 training performance. At the minimum, you will have parity, and increasingly more when you look at a comparison between a H100 and 𝗦𝗽𝗃𝗃𝗃. So this is purely performance. And like I mentioned, your overall TCO is what you want to be looking at. So let's talk a little bit more on pre-tuned and containerized solutions. What we want to do is not just give you the pieces, but we want to make sure those pieces actually work well together. So what we have been doing is getting to a biweekly release of putting these solutions together, validating them, and then getting them out to you every 2 weeks. What this means is the latest changes, the latest algorithms, the latest modifications that we've made to the stacks are all available to you every 2 weeks. So let's take a look at how this works for inference. So when we look at inference, we have two solutions that we provide, two major solutions. Obviously, we have other ones too. So you have the VLLM path, or you have the SGLang path. And based on which model is best served with one framework, we may recommend one or the other. So for example, if you want to serve DeepSeek, we would recommend SGLang. If you're serving llama, we'll recommend VLLM. Again, this is the beauty of the open ecosystem that we play to. We don't have to average both of them to give you one that's kind of half and half. We take the best of what's there, we validate it, and then we make it ready for deployment and hand it over to you. So we get containers, we get user guides, and more importantly, we have performance results. So there's no more guessing, can this run in your MI300X instance on Azure? We will actually provide you the performance table that we expect. And so when you spin up those instances, you get exactly what numbers we've seen. And so there's no guessing game, and you know what this would unlock for you at scale. So this is for VLLM and SGLang. So now let's take a look at training. So for training, again, we want to meet you where you are. So if you're focused on optimized for MFU, then we'd recommend JAX Max Text. If you're focused on a native PyTorch-based ecosystem, then we would recommend obviously PyTorch with TorchTune and TorchTitan. But if you're optimized for like transformer architectures, and you need your current workflow involves Megatron or Megatron LM, then we have a Megatron LM-based image. Again, all of them are available as containers. All of them are come with good user guides, and most importantly, they come with corresponding performance results that you could use to validate how the deployment is going for you or is going to be for you. So let's talk about the next part of the ecosystem. The ecosystem is very important because it is a sign of collaboration between us at AMD and other open source companies and ecosystems that could span the entire AI surface. So for example, PyTorch, JAX, TensorFlow, et cetera. So let's go talk about the how do we get from a seamless developer journey to deployment. So this is going to get a little technical in terms of like how we go about kernel tunings. So what this does is it provides you a way as a developer to choose the best tools that AMD provides for you to be able to deploy at scale. So if you want something that is plug and play, that just works, and it's a standard LLM. So for example, DeepSeek or Llama, then we would recommend you use our Aether backend. And Aether, and we're going to talk about Aether in a brief second, but that's like prepackaged for performance. It contains the most optimized kernels that are available for performance. Then there is something called Triton that we leverage for a very fast, gets you 80% of the way, and it could be for quickly optimizing kernels, but it may be a little out of the beaten path, and for you to be able to unlock that value. With Triton, we have, if you have mid-level customization, you could use the stream K path. But if you have like advanced optimizations that you'd need, then we'd recommend CK or composable kernels. And then for the really most performant kernels, then we recommend assembly. You can always drop down to assembly. This is, again, the beauty of an open ecosystem to try and meet the customer where they are, right? And meet the developer where they are. So if you just need Halo models, we have fully optimized libraries. But if you have some optimization, you can take the middle path. But then if you need hyper optimization, you take the HIP and assembly path. So let's talk about Aether. What is this Aether? So 𝗦𝗲 is a centralized repository of high-performance AI kernels. This has been worked on by AMD engineers who may have even designed the hardware themselves. So they know exactly what to do to the hardware to make it sing. And we write those kernels and make them available for everyone and can be integrated into any platform. It can be integrated into PyTorch, can be integrated into VLLM, into SGLang, et cetera. So this addresses an important gap. When we have a easy-to-use solution, you may not have the most performant solution. And then you spend hours or days optimizing that solution to get to the most performant solution. And what we provide here is the most performant solution for standard LLMs and Halo models. And since it's plug and play, you can use it for any of the available frameworks. This gets another layer down into code, but it is still very easy to understand. It's Pythonic. It's just Python code, but then you just import it, and then you call a tgem.mm, and that magically goes and calls the assembly optimized kernels for these Halo models. So what this provides you is the ability to leverage our highly optimized kernels in your workflows and unlock the same kind of performance. And the performance gains. This is an important slide. I'll say this is slide 3 for you to remember. So if you look at the gains that we've gotten for transformer MHA or for decoder, it's in the order of 14x to 17x improvement. The advantage here is that you suddenly get into another level of performance, similar to what you have for that DeepSeek blog that AMD and Azure had published. It gives you an immense amount of throughput boost, as you can see in the second chart. We were at like 6,400 tokens per second, and it went to about 13,700 tokens per second by just switching the underlying library infrastructure. And that's all provided by default now. But it just shows you how we are able to unlock this performance. So just to recap, the idea is that the software footprint for all what you do is available, but it's also performant. Up to 17x at the kernel level, and up to 2x at like end-to-end level for models like DeepSeek. Let's spend a few minutes on Triton. Triton is a programming language that came out of OpenAI, and AMD has invested heavily in Triton. What Triton does is it's bridging the CUDA moat and AMD ROCm. So what it does in effect is it lifts the GPU programming paradigm into Python. It makes end users able to program in Python. But then it allows us to target any hardware in the back end. And it's compiler assisted. So writing optimized kernels without Triton could take a while, but Triton gives you the first 80% relatively easily. And then it allows you to optimize further. So let's look at a small snippet of code here. I don't expect you to understand it, but the point is the way you write the kernel stays the same, and it's in Python. And it can target the incumbent ISA, or it can target AMD's architecture and AMD's, any of AMD's GPUs. And then we invest heavily in this. So if you look at what this provides, you no longer have a porting problem, because you're not writing it in CUDA or PTEC, and you're not porting to AMD. You're just writing it in Triton. So it's the great equalizer of GPU programming languages, because now you just write it once, and it runs on any GPU that you target. And we have invested heavily in it because it removes the need for this CUDA to AMD transition, and it allows you to just go write it once and run it performantly on AMD hardware. So here are some performance gains with Triton. This was measured with 𝗲𝗲𝗀𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 increasingly started to get performant, as good as native libraries like 𝗦𝗲𝗀 that were written, handwritten with C++ and assembly. And Triton kernels are almost as good. And I think with the latest Triton 3.3, we've made even further improvements that make it, indistinguishable, but gives you the flexibility of programming in Python. So let's talk about improved profiling tools and debugging tools. So this is an important area for us, too. This is a screenshot of a new tool that is called the ROCprof Compute Viewer. That's going to be available. It probably is available now, or in the next few days or weeks. It should be available, and it definitely will be part of the ROCm 7 release that is going to be coming out soon. Just like how we focus on developers and giving them the ability to build and run our code, we also want the developers to be able to identify hotspots and figure out where exactly they have to go and fix code. So the new tools that we are rolling out in the next few weeks and months will get you from a Pythonic programming language to a hotspot at an instruction level instantaneously. What this provides you is the ability to just look at the visualizer and go back and make those changes and make that a tight loop in terms of your development experience so that it's easy for you to develop on AMD. So we also have entire application tracing across the system. It's not just for the compute kernel alone. So we want you to be able to have an integrated experience on a node level, but we're also doing that at a cluster level so that you can track performance problems across a cluster. And like I'd mentioned before, we've been doing that successfully with the national labs, but now we're starting to do that with hyperscalers at a much larger scale. So all of these tools, we are happy to walk you through if you're interested. Stop by our booth and ask about this, and we'll talk about that at the booth. We're also increasingly spending time on not just building, good engineering tools, but making those tools accessible, making them documented well, making them usable, making them discoverable. And to that effect, we've made something called an AI Developer Hub. We have something called the AMD Infinity Hub that allows you to find containerized solutions. And obviously, we've started a wide range of blogs and marketing material that's available for developers so that it's easy to start developing on AMD platforms. So here are some of the examples of, I'll just walk through a few of these. We've started to put in Docker containers for VLLM, SGLang, Megatron LM, PyTorch. And then we have Jupyter notebooks that are available for inference, fine-tuning, training. And then public performance results. This is another area that we have invested a lot of time, because we had noticed that there's always a mismatch in, oh, I have this software and this hardware, and how do I get this performance? And it makes it very confusing for the end customer to deploy. So we've spent a lot of time to make sure that all of our performance results that we publish now come with a Docker and instructions on how to recreate it. And this has gone a long way in building the confidence that we're not just shipping the software, we're shipping performance software. And it's reproducible, and it's refreshed every 2 weeks. Again, that is something that I'm very proud of that the team has been able to do. Every 2 weeks, we push out an inference and a training Docker. And this has the latest updates to all of the kernel libraries, the frameworks, and it's validated so that you can actually consume it, and then take it to production very quickly. And the amount of open source projects that we pull in and test is also huge, right? So there's like 14 listed here. But all of these, we also contribute to the CI/CD systems in the upstream projects. This is to ensure that any future change that they make does not inadvertently break our shipping software. And then we have CI/CDs built into our testing infrastructure and then into our release infrastructure before we make that code available for you to deploy. So we're very proud of all the software development work, but also how it's more easily discoverable now. And to talk about the Infinity Hub, it's ready to use, easy to use instructions, and there are multiple applications. So these are like, you can take verticals, molecular dynamics, quantum chemistry, oil and gas, and each of those have unique settings or capabilities that we've validated. And obviously, all of the common AI frameworks, that's all built in, right? And then here are some of the ways in which you can actually get from the AI Developer Hub or the Infinity Hub. It's just one click, gives you documentation, and gives you performance results. Again, this has been a very good tool for customers, because now they can just be ROCm, I want to run DeepSeek, and what would I get on an Azure MI300X? Should be a straightforward mapping to get, to see what the performance would be. And ROCm blogs, we've started this initiative to educate and increase ROCm awareness. And immense amount of blogs and interactions have started with the blogs that go out, and customers have come to us. And once you put it out in a blog form with the performance and how to recreate something, it clicks, and then customers are like, that's exactly what I want to do. And it's easy for them to spin up an Azure instance and give it a try. So all of these, they range from, like image generation, video generation, kernel optimization, and training workloads, et cetera. And then, here are some of the blogs. Like, actually, the first one is on 8-tier kernels and DeepSeek R1. So we've been getting increasing amounts of usage, but we will continue to invest heavily in the documentation aspect of ROCm, so that it's easy for you to discover the content that we have been creating. So those are all the slides I had. Here's a QR code for you to access the session details. And if you had any questions, I'll be here after the session. And we'll also be by the booth if happy to answer any questions. And thank you for joining us.